Okay, so we've taken a look at doing the conversions from decimal to binary and binary to decimal, and understood that the weight associated with each place or each digit is used in calculating those values. So now what we want to look at is the hexadecimal system, the base 16. The hexadecimal system actually saves us some time in doing our conversions, and hex is actually used in the process and in computers and microcontrollers. The base 16 or hexadecimal system, as it's called in the computer literature, is used then for a convenient representation of binary numbers, and you're going to see that it's easy to do that conversion. For example, it's much easier for us to represent a string of ones and zeros, such as the 1 0 0 0 1 0 0 1 0 1 0 1 1 0 of base 2 as its hexadecimal equivalent, which is 896 and the letter H. The binary system then, as we know, uses the two digits 0 and 1. The base 10 system uses 10 digits 0 through 9, and those 0 through 9, as we're going to see in hex, as you recall, are the only numbers that are in our understanding of numbering systems. So we're going to use that along with some alpha characters. So 0 through 9 are used in hex, but we also need the letters A, B, C, D, E, and F as the numerical values, weight associated, again, numerical values, when we look at hexadecimal numbers. So if we take a look at this table, the table shows us the correlation then between each of the numbering systems. The decimal system, in this case, we're going from 0 to 15 because our target here is to look at hex. The binary value, least value of 0, 0, 0, 0, all the way up to a string of ones being all of the weighted values in binary. But you can see in hex, all we need is one character from 0 through F. So the thing to keep in mind as we're going through this course and as you're moving through the material and understanding the programming, when you have to assign values that are F, you're maxing out all of the places. Sometimes you'll see numbers referred to as FF. If you had any networking experience, those values are telling you everything is set. Everything is a 1. So in looking at a conversion, if we want to represent a binary number as its equivalent hex, we start from the right, we group the numbers together in groups of 4, and replace each 4-bit number with its hex equivalent. To convert from hex to binary, each hex digit then is replaced with its 4-bit binary equivalent. So if we take a look at this example, we want to represent that long binary number 1 0 0 1 1 1 1 1 0 1 0 1 in a hex number so that it's easier to handle. Again, keep in mind that in the computer, all the computer understands are ones and zeros, so it has to do these conversions back and forth. So the first thing to do then, the number is grouped in sets of 4. So we go 1 2 3 4 1 2 3 4 1 2 3 4. This one is nice because we have an even number. 1 0 0 1 1 1 1 1 1 0 1 0. Then we group each of the 4 bits is replaced with the hex equivalent. So 1 0 1 0, well, if we look back at our table, 1 0 1 0 represents the hex number 9. Again, like we said before, 1 1 1 1, the hex number F, and then 0 1 0 1, the hex number 5. So very quickly we were able to convert this number from a binary long string number to a very simple hex number 9F5 base 16. To convert then from hex to binary, we go the opposite way. Each hex digit then is replaced by its 4-bit binary equivalent. So if we're given a hex number of 29B hex and we want to convert it to binary, all we have to do is we can look at the table, or if you've got them committed to memory, the number 2 is a binary 0010 because that's the only weighted place where there's a value. The number 9, 1001, the weighted value of 8 plus a 1. And then the B value is, of course, the number 11. So you would look at that and say, okay, well, I need an 8, I need a 2, and I need a 1. Okay, so that then becomes the binary number 101001111 in our conversion. Converting from decimal to hex, we do a little different process. So to convert from decimal to hex, you can approach it in two ways. One, you can first convert it to a binary and then to a hex, or you can convert directly from a decimal to a hex by repeated division and then keep track of the remainders. So we'll do that next.